Hi everyone. Today we are going to see about the special concretes. That first one is a lightweight concrete. The lightweight concrete become more popular in recent years. Here the modern technology and a better understanding of the concrete has been helped much in promotion on the use of lightweight concrete. The particular type of lightweight concrete called a structural lightweight concrete. The main aim of the lightweight concrete is to reduce the density of the concrete which compare with the normal conventional concrete. One of the disadvantage of normal conventional concrete is the high self-weight. It has density of 22 kN per meter cube to 26 kN per meter cube. The heavy self-weight will make it to some extent an uneconomical structural materials. Here the lightweight concrete whose density varies from 3 to 18 kN per meter cube. The self-weight of the structural elements automatically reduced when reducing the density of the concrete. There are some methods for the lightweight concrete to produce a lightweight concrete. First one is by replacing the usual mineral aggregate by cellular porous or lightweight aggregate. By introducing gas or air bubbles in mortar, this is known as aerated concrete. By omitting sand fraction from the aggregate, this is called no-points concrete. About the classification of lightweight concrete, it is classified into two categories. First one is a lightweight aggregate, second one is a natural lightweight aggregate, second one is artificial lightweight aggregate. In the natural lightweight aggregates, there are some natural lightweight aggregates are pumice, diatomites, area, volcanic cinders, sawdust, rice husk, and etc. Some of the artificial lightweight aggregates are artificial cinders, coke, grease, foamed slag, bloated clay, expanded shells, sintered fly ash, exfoliated vermiculite, expanded perlite, and thermocol beads. These are some of the artificial lightweight aggregates. When coming to the natural aggregate pumice, these are the rocks of volcanic origin. Then occur in many parts of the world. They are light and strong to be used as a lightweight aggregate. The lightness is due to the escaping of gas from the molten lava when erupted from the deep beneath of the earth crust. It is mined, washed, and then used. Out of the natural aggregates, pumice is only one which is used rather widely, and it has been used in the Roman structures. This figure shows the pumice. Scoria. The scoria from volcanic origin, which is usually dark in color, contains large and irregularity in shape cells unconnected with each other, and it's slightly weaker than pumice. Volcanic cinders. These are the loose volcanic product resembling artificial cinders. Coming to the sawdust, you know that it is used as a lightweight aggregate in flooring and in manufacture of precast products and roofing tiles. It affects adversely the setting time and hardening of Portland cement owing to the cement of tannins and soluble carbohydrates. The shrinkage and moisture movement of the sawdust is also high. The process of boiling in water and ferrous sulfate solution has been tried to remove the effect of tannins, but the cost of process limits its application. Coming to the rice husk, the rice husk, ground husk, and bagasse have been used unlimited for lightweight aggregates. These are some structures which shows the which was constructed by lightweight structural concrete convention. Hall built of the Lake of Branson, Missouri in USA. This is the artificial aggregates. Brickbats, one of the type of aggregate where natural aggregates were not available or costly. It is only used for plain cement, not for reinforced concretes. Others are the cinder, clinker, and breeze. Coming to the foamed slag, the foamed slag is one of the most important type of lightweight aggregates. It is made by rapidly quenching blast furnace slag, a byproduct produced in the manufacture of pig iron. The texture and strength of the foamed slag depends upon the chemical composition and the method production, but in general the structure is limited to pumice. the free form of contamination of heavy impurities, free from volatile impurities such as coke or coal, free from excess of sulfates. Coming to high strength concrete. In India, the high strength concrete were used in prestressed concrete. In 50s, prestressed concrete structures were built using 35 to 45 MPa strength concrete. During 90s, concrete having 45 to 60 MPa strength were used in construction of buildings. But in India, concrete having strength of 75 MPa was used in construction of bridge in Mumbai. Other notable example, construction of containment dome at Kaiga power projects. How high strength in concrete is achieved? By using higher cement content, reducing water cement ratio, better workability, and hence better compaction. This will use to improve the strength of the concrete always. Some of the special methods of making high strength concrete: seeding, revibration, high speed slurry mixing, use of admixtures, inhibition of cracks, sulfur impregnation, use of cementitious aggregates. The advantage of high strength concrete is high strength to weight ratio, particular for lightweight high strength concrete. High early strength allows faster construction and formwork reuse, increased elastic modulus and lower creep. Very tall buildings become feasible. Advantages of high strength concrete: lower column cost for concrete and steel, smaller column allow for more floor space, box girder and solid girder bridge, spans may be increased and designs simplified to build the superstructures of long span bridges and to enhance the durability of the bridge decks. Some of the disadvantages of high strength concrete is: considering the fact that the final setting time of the most brands of cement is around 120 minutes, there will be a lot of questions answered regarding the durability aspects. Increased cost per unit volume, more stringent quality control of materials and construction needed, and the structural members may exhibit a brittle failure. Coming to SUFCON, that is a slurry infiltrated concrete. SIFCON is the slurry infiltrated fiber concrete. The strength of the concrete is high with fluctual strength and is suitable for earthquake prone areas. The cement slurry is introduced over the steel fibers. The coarse aggregate is omitted here. Coming to SIFCON over FRC, the strength of the SIFCON is higher than the ordinary fiber reinforced concrete. That is slurry infiltrated concrete. When compared with the fiber reinforced concrete, the strength of the SIFCON is higher than the ordinary fiber reinforced concrete. In fiber reinforced concrete, there is a risk of balling and clustering. The fiber content is limited to 2 to 5% in FRC. Whether the SIFCON possesses a high flow ability and passing ability. What are the tests for SIFCON is that when we add slurries in the concrete, the slurry infiltrated the steel fibers, the test for compressive strength, split tensile strength, the impact test and fluctual strength test can be conducted. The materials are OPC53 grade coiled steel fibers. That we are using coiled steel fibers in the mixture. 0.2 to 0.5 mm thickness, super plasticizer and ordinary sand. This tests are conducted for alternate wetting and drying for 3 days. About a shotcrete technology, this is the shotcrete. The picture shows that shotcrete technology. Actually, what is shotcrete is providing quality products and service to the industry. Since in 1979, the innovative technology of shotcrete was introducing to make the work easier and immediate. Here the definition of the shotcrete is the mortar or high performance concrete conveyed through a hose or pneumatically projected at high velocity on a backing surface, an acceptable way of placing cementitious material in a variety of applications. The shotcrete and high performance product consisting of plus non-alkaline accelerator. Next one is the shotcrete versus gunite. The shotcrete is today an all-inclusive term that describes spraying concrete or mortar with either a dry or wet mixing process. Connect is a trademark name that is incorrectly used to describe the dry mix shotcut process. The shotcut is emerged as the only acceptable industry to term the correctly describe pneumatically applied concrete. The shotcut is today an all-inclusive term that describes spraying concrete or mortar with either a dry or wet mixing process. Connect is a trademarked name that is incorrectly used to describe the dry mix shotcut process that we have seen already. Coming to the reinforcement, the sprayed concrete is reinforced by conventional steel rods, steel mesh, and or fibers. The fiber reinforcement is also used for stabilization in applications such as slopes or tunneling. There are two classifications. The shortcuts are dry process and wet process. There are some applications of the shortcuts: rehabilitation of subway tunnels, construction of domed roofs, highway culvert repair, and arch culvert repairs. There we can go for the shortcut. Coming to the conclusion, the use of shortcut to build the new concrete structures as well as to restore and repair existing structures is well known and documented, and it is perhaps the most diverse method available in concrete construction. The use of this innovative technology is increasing day by day, and procedures for its proper performance are well developed, and high quality work is regularly obtained. Coming to the ferro cement, in 1943, Pierre-Louis Nervi tested and presented in this paper that a new structural elements, an extremely thin plate of concrete made of layers of small diameter wire mesh and a cement mortar with a stand used as a binder. Actually, what is a ferro cement? Is a type of thin wall reinforced concrete commonly constructed of hydraulic cement mortar reinforced with closely spaced boss layers of continuous and relatively small size wire mesh. The mesh may be made of metallic or other suitable materials. Mortar provides the mass, and wire mesh imparts tensile strength and ductility. When building ferro cement structure, the sand cement mortar is applied to the reinforcing wire with a trowel never poured like common concrete work. Often a foam is used to provide the desired shape. The ferro cement is a superior reinforced concrete. It differs from the conventional concrete in that there is a higher ratio of steel of cement mortar. By altering the cement steel ratio to make a ferro cement, which exhibits a property superior to either steel or cement separately. Ferro cement has many of the properties of steel, and it will not rust. Although it looks and feels like a concrete, it can flex without cracking. This figure shows the wire mesh, that is a ferro cement. Typical cross section of the ferro cement. The techniques which are used for manufacturers are hand plastering, semi-mechanized process, centrifuging, and ganiting. Materials used in ferro cements are cement mortar mix, skeleton steel, steel mesh reinforcement, or reinforced fiber reinforced polymeric meshes. Some of the disadvantages and advantages of ferro cement. When we coming to the advantages of ferro cement, it is highly versatile and can be formed into almost any shape for a wide range of uses. 20% savings on materials and cost, suitability of precasting, flexibility in cutting, drilling, and jointing, very appropriate for developing countries, labor intensive, good fire resistance, good impermeability, low maintenance cost. Disadvantage of ferro cement is a low shear strength, low ductility, susceptibility to stress rupture failure. It can be punctured by collision with pointed objects, corrosion of the reinforced material due to the incomplete coverage of metal by mortar. It is difficult to fasten to reinforcement with bolts, screws, welding, and nail. Large number of labors required. Tying rods and mesh together is especially tedious and it's a time consuming. And some of the applications of ferrocements are marine application, water supply and sanitation, agricultural, residential buildings and rural energy, miscellaneous. These are some of the applications of ferrocement. Coming to the ready-mix concrete, we know that ready-mix concrete, which is popularly called as RMC, the first ready-mix concrete which was built in 1930s, the consumption of cement in the form of RMC is about 5% in India, whereas in developed countries it is about 70%. The leading RMC supplier worldwide is Mexican Concrete and the cement company Cemex. What is the definition? The concrete which is specially manufactured for the delivery to the consumer construction. The site is in a freshly mixed plastic and unhardened state. It's called ready-mix concrete, where the need for ready-mix concrete is a requirement for higher grades of concrete, correct accountability ingredients, rapid development of infrastructure industries, increased demand of concrete, possibility of manufacture of desired grades, mega project demands higher input, timely supply of reliable concrete. Some of the advantages of ready-mix concrete are quality assurance, elimination of manual errors, mass production, water cement ratio maintained, reduced materials wastage, labor cost saved, design mix as per higher standards resulting in standard deviation and improved characteristics. Some of the disadvantages are the materials are batched at a cement plant and mixing begins. Generation of additional road traffic. For furthermore, access roads and site access have to be able to carry the weight of the truck and load concrete limited time span mixing and going off. The RMC batching plant, the figure shows the RMC batching plant. RMC delivery truck, this is the RMC delivery truck. Coming to fiber reinforced concrete FRC, containing a hydraulic cement, water, fine and coarse aggregate and discontinuous discrete fibers is called fiber reinforced concrete. It may also contain pozzolanous and an admixtures commonly used in the conventional concrete. Here the fiber is a small piece fiber in a small piece of reinforcing material possesses certain properties. They can be a circular or flat. There are many types of fibers can be used in a fiber reinforced concrete, either natural or artificial. Natural cotton fiber, coir fiber, sisal, and then the artificial steel, carbon, glass, polypropylene, nylon and asbestos fibers can be used. Steel fiber is one of the most commonly used fiber. Mixing of FRC